everyone. I am Nirisha, Assistant Professor in the Department of CSIT working in MLR Institutions of Technology. Today we are going to discuss about recursion in C programming language. So coming to the overview, we are going to discuss about the function recursion and also the syntax of the recursion function, and next to some two example programs of this recursion functions. Coming to the function recursion. In C programming language, function calls can be made from main functions, other functions, or from the same function itself. So note this point, we can also call from same function itself also. The recursive function is defined as a function called by itself is called function recursive. So function is called by itself is nothing but a recursive function. The recursive function should be very carefully, because when a function called by itself, it enters into the infinite loop. And when the function enters into the infinite loop, the function execution never gets completed. We should define the condition to exit from the function call so that the recursive function gets terminated. So we are telling about the function, recursive function, that the function is calling itself again and again. So it is calling itself again and again for some number of steps. The function is calling itself is called as recursive function. A function is calling itself for again and again for some number of times. So if the same process is repeating it, we cannot stop that function calling. So to stop that function calling, we need to do some condition. We need to set some condition. So based on that condition, the function calling will get terminated. So in this recursive part, we have some recursive function. We have some two parts. One is base function and other one is the recursive part. So coming to the syntax. So the syntax is return type, function name, and what are the parameters that you are passing to that function. And this is nothing but the function declaration. So as we are dealing with the functions, we need to remind some 3 points: the function declaration, function call, and the function definition. So this is a function declaration, and inside the main function, we are calling that function. So it's nothing but a function call. So whenever we call this function call, it returns to the function definition. And here this is nothing but the definition. This part is the definition part. And the next here in this function, we are calling that function again. The same function we are calling it. So this is nothing but the recursive function. So these functions are called as recursive function, and this process is known as recursive part. So to terminate this function call again and again, we are using some base condition. So here in the recursive part, in recursive functions, we have some two parts. One is base part and the other one is recursive part. In this recursive part, the function calling itself, the function will call itself. And in this base part, we are writing one condition to stop that function calling. So this is about the recursive functions. It's nothing but we are calling the function again and again until we finish our task. So to stop that function calling at some point, we are using this base part inside this recursive function. So coming to the one example program. So we are finding the factorial using recursion. So for that, we are using the header file, and this is a function declaration. This is a function declaration. So factorial is my function name, int is my return data type, and this int data type value we are passing to that factorial function. And inside this main function, we are using some two variables. One is result and other one is the n. N is to store the input value and result is to print the output value. So here we are asking to enter an integer to find the factorial of a number. And by using scanf statement, we are reading those values, whatever the value you have entered. And the next, we are calling this function. Factorial function we are calling with n value as a parameter. So whenever we call this function, the function will return to the function definition. So int is my return data type, factorial is my function name, and this n will be copied over here to this n, whatever the n value we have read. And the next, see here, to find the factorial, we already know about the factorial. So to find the 5 factorial, we are going to multiply this 5 factorial is equals to 5 into 4 into 3 into 2 into 1, that is equals to 120, 120. So to get the 5 factorial, we are following this process. So for that, what we are doing, see, this is nothing but the base condition. This is the base part, and in the else part, we have written about the recursive part. So in this recursive part, the function calling, this function is calling the same function again with some other different values. So this is called the recursive part. The function is calling itself in this recursive part, and this is called as the base part. In this base part, the function call get terminated. So here, check the condition. If n is equals to 1, we have the n value. For suppose we are taking the n value as a 5. So if 5 double equals to 1, no, the condition is false in the if. So it will come to the else part. As we know, it is an if else. If the condition is false, we are coming to the else part. And in this else part, we have some return. We are returning 5, n into n is 5. 5 into, again, we are calling this factorial function with n minus 1. So n value is equals to 5. So n minus 1, 5 minus 1 will be is equals to 4. So we are calling this factorial function again with parameter n value as a 4. So the function call again will go to the function definition whenever the function call happens. So now factorial of 4. So now check the n value as a 4. 4 will be copied to this n. And 4 double equals to 1. No, the condition is false. So we are coming to the else part. And in this else part, we have n into n value is 4 and 4 into factorial of n minus 1. N minus 1, 4 minus 1, that is equals to 3. And next we are calling the factorial function with 3 as an input. So again the function definition, again whenever function call happens, it moves to the function definition. So again we are checking whether n is equals to, we are checking with this condition. N is equals to 1 or not. No, n is 3 is not equals to 1. So it will come to the else part, and in the else part we have given return n into, that is 3 into factorial of 2. So now the factorial function we are calling with 2 as an input. And again we are calling this n is 2 is equals to 1. No, false. So it will come to the else part, and 2 into factorial of 1. So we are calling this factorial function with n value as a 1. Now check the condition, the base part. 1 is equals to 1. Yes, true. So if it is true, then what we are asking to return? We are asking to return 1. So the value of this factorial 1 is equals to 1. So 2 into 1 is equals to 2. So this 2 will be returned to this factorial 2 function, because the factorial 1 function was called by the factorial 2. So the whatever the value we have got by this, that value will be returned to this factorial 2. So now the factorial 2 value will be is equals to 2. So 3 into 2 will be equals to 6. So the 6 value will be returned over here. And next factorial 3 is equals to 6. So 4 into 6 will be is equals to 24. So the 24 value will be returned to this fact of 24. So the 24 value is fact of 24. And now 5 into 24 is equals to 5 into 24 is equals to 120. So which function called this fact of n function called inside the main function. So this 120 value will be returned to this factorial of n. So that 120 value will be assigned to the result value, and by using this printf statement we are printing factorial of, this is the n value. N value will be reflected in the first percentile d, and the result value will be reflected in the second percentile d. So the factorial of n is equals to whatever the value we have got in the we have stored in the result value, that is 120. So observe the test cases. Enter any integer. We have given the input as 5, and we have got the output as factorial of 5 is equals to 120. So whatever the input you are giving, so it stops till we get the factorial is equals to, we get the n is equals to 1. Whatever the positive integer you are giving, so this code will be worked to that particular value. So you'll get all the factorial values by using this code. And the next is the Fibonacci sequence. So we are finding the Fibonacci sequence by using the recursive function. So as we know the Fibonacci sequence, so in this Fibonacci sequence, we are taking the input as an n. So for suppose if we have n is equals to 5, and the first term we are taking it as a 0, and the second term we are taking it as a 1. The next term will be the addition of these two terms. So 0 plus 1 will be equals to 1. The next term will be the addition of last two terms, that is 1 plus 1 is equals to 2. The next term will be is equals to 2 plus 1, that is equals to 3. So if you are giving the n as 5, so we got the 5 sequences over here. So this is known as a Fibonacci sequence. So take an example here. We have given the 7 as an integer. So the first number is 0 and the second number is 1. We are taking that first term as 0 and second term as a 1. And the next term will be the addition of these two numbers. So the addition of these two numbers is 1. The next term will be the addition of last two numbers, that is equals to 1 plus 1, that is 2. The next term will be equals to the addition of last two terms, that is 1 plus 2, it is 3. And next term will be the addition of last two terms, that is 2 plus 3 equals to 5. And the next term will be the addition of last two terms, that is 5 plus 3 is equals to 8. In this way, we need to find the Fibonacci sequence. So this is the concept of the Fibonacci sequence. If we are giving the n value, so that many sequences we need to generate by using some code. So here for that, we look for an example program. So here we are taking the void as the data type, and next this is a function declaration. So this void is the return data type, and fib is the function name, and integer value we are passing to this Fibonacci fib function. And now next, inside this main function, any function we need to call from the main function, because the compiler starts reading from the main function. So if you ignore that main function, whatever the code you are writing, that won't get accepted, or it will not run. So next we are declaring one n value, and by using printf we are asking to enter an integer, and by using the scanf we are reading that n value, and then next we are printing that 0 and 1. So as we said that the first two terms will be the 0 and 1. The first term will be the 0 and the second term will be the 1. So we are printing those 0 and 1 values initially. And next we are generating the other terms based on our n value. So now next we are calling this fib of n minus 2. So why we are calling fib of n minus 2? Because we have already printed the first two terms. So if you are taking the input as 5, so we have already done with the first two terms, that is 0 and 1. So we require next 3 more values. So then the 5 number of sequences will get, Fibonacci sequences will get completed. So that is the reason why we are calling this fib function with n minus 2 as an input. So we are calling this function. So as soon as we call, it will jump to the function definition, and the next this n minus 2 value will be copied to this n. So for example, in the test cases, we are taking the n value as a 7. So consider n is equals to 7. N is equals to 7. So my n is equals to 7. The next we are calling, by using this printf statement, we are printing 0 and 1. So 0 and 1 will get already printed. And next we are calling this fib function with n minus 2. So my n is 7. So if you are calling this fib function with n minus 2, that is 7 minus 2, that is equals to 5. So now to this fib function, n value is equals to 5. So fib of n minus 2. So n is equals to 5. And next we are taking the keyword as a static. So if we take the keyword as a static, so whatever the values we have, this a and b values in the previous function, that values we are going to use. So now see here, a value is equals to 0 and b value is equals to 1. And now next to check the condition, n greater than 0, n is 5. So 5 greater than 0, yes, true. So if it is true, then what it happens, c is equals to a plus b. So we are writing the code as c is equals to a plus b. A value is 0, b value is 1, 0 plus 1 will be equals to 1. And by using this printf statement, we are printing the c value. C here is equals to 1. So the 1 value will get printed. And the next b value we are assigning to a. What is the b value? 1. So that 1 we are assigning to a. And c value we are assigning to b. The c value is also 1. So c value we are assigning to the b. Next again we are calling this fib function with n minus 1 as input. So now n is equals to 5. If it is n minus 1, then 5 minus 1 will be equals to 4. The fib function we are calling with n as an input. So again it will return to the function definition if you are calling this fib function. So again we are finding here static a is equals to 0, b is equals to 1. So here we have given the keyword as an a is equals to 0, b is a is static keyword before this variables. So that is the reason why a value will be equals to 1 and b value will be equals to 1. So whatever we have in the previous values, that values will get retained if you are using the static keyword. If you are not using the static keyword, the A value will be 0 and B value will be equals to 1. We are using static keyword, so the previous values, previous function call values, whatever the values have been changed, that values will be reflected. So now again, check the condition. Now A is equals to 1 and B is equals to 1. N greater than 0. N is 4. 4 greater than 0. Yes, true. So if it is true, C is equals to A plus B. C is equals to A plus B. And here A and B value is equals to 1. 1 plus 1 will be is equals to 2. And by using this printf statement, we're printing that value. C value is 2. And next B value we are assigning to A. B is 1. We are assigning to A. And this statement C is equals to B. C value is 2. So the 2 value we are assigning to the B. And again we are calling this fifth function with n minus 1, that is n is 4. So 4 minus 1 is equals to 3. And next we are calling this function fifth function with 3 as an input, n value as an 3. So again here we are coming static int A is equals to, now the A value is 1 and B value is equals to 2. So now C is equals to A plus B, that 1 plus 2 will be is equals to 3. And by using this printf statement, we are printing that 3 value. And next B value, that is 2, that we are assigning to the A. And C value, it is 3, that we are assigning to the B. And again, we are calling this fifth function with n minus 2, that is 2. And again, we are checking the condition over here. 2 greater than 0. Yes, true. So again, C is equals to A plus B. 2 plus 3, that is equals to 5. And by using printf statement, we are printing that C value. And next B value, we are 3, that we are assigning to the A. And C value is 5, that we are assigning to the B. And next fib of n minus 1, that is fib of 2 minus 1, that is equals to 1. So again, check the condition 1 greater than 0. Yes, it is true. So if it is true, we are calculating the C value. C is equals to A plus B, that is 3 plus 5 is equals to 8. And next, by using printf statement, we are printing that C value. And next B value, that is 5 we are assigning to the A and 8 we are assigning to the B. And we are calling this fifth function with 1 minus 1, that is equals to 0. We are calling the fifth function with 0 as an input. So here check the condition, 0 greater than 0, the condition is false. And here we don't have any else but. So this fib 0 function will return to the fib of 1. Because fib of 1 called it, and this function will return to the fib of 2. This function will return to the fib of 3, and it will return to the fib of 4, and it will return to the fib of 5. So finally it will come over here, and no more statements here to execute, so the program ends. So see here, you can check here the test cases. N value were given as a 7, and the values are 0, 1, 2, 3, 4, 5. 0, 1, 2, 0, 1, 1, 2, 3, 5, and 8. So this is the test cases that we have got to find the Fibonacci sequences. So I hope you understood why we are taking all these statements. In each and every function call, we are adding those two numbers, and that B value we are assigning to A and that C value we are assigning to B. So why? Because the last two integers we are adding to get the next term in the Fibonacci sequence. So that is the reason why these two steps have been added. Thank you.